Okay, beautiful. Sorry, the video got cut off there. So we discovered that our common ratio is that we were multiplying by 4. So we took that 64 and multiplied by 4. 4 times 4 is 16. Carry the 1. 4 times 6 is 24. Plus 1 is 25. So we have 256 would be our next term in the sequence. So go ahead and plug that in. And then we'll go to question 15. Is this geometric or arithmetic? So 3, 6, 9, 12. Geometric, remember that's what we're looking at this week. That's when we're multiplying. And arithmetic is what we looked at before break, which is when we're adding or subtracting. So 3 times 2 does get us 6, and 6 times 2 is 12. So it's not going to be our multiplication. So let's see if addition works. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. So that does work. So we're adding 3 each time, which is going to be an arithmetic sequence. Brilliant. What is the common ratio here? So we have 3, 15, and 75. So 3 times what is 15? And remember, we can also do 15 divided by 3 to figure out what that is. And we will get 5. So we're multiplying by 5 here to get our next term. Which formula is used to find the explicit equation for geometric sequences? So since it's geometric, right, we're thinking of multiplication or division. So it cannot be this one because that has addition. And it can't be this one because that also has addition. So a sub n, the first thing we put is our first term, a1, and then we multiply it by the common ratio raised to the n minus 1 power. So that's going to be that last option there. Beautiful. Question 18. Determine whether the sequence is arithmetic, geometric, or neither. So with this one, it might not be as easy to figure out what the multiplier is because we have decimals. We don't know those facts as well. So if we take 4.5 and divide it by 1.5, let's see what we get in our calculator. 3. So 1.5 times 3 is 4.5. So that has a multiplier of 3. So let's do 4.5 times 3. That gets us 13.5. So that works. And then let's just test the last one. 13.5 times 3 is 40.5. Nice. So this is geometric. We have a multiplier. Our multiplier is 3, and it's the same to get from one term to the next. Beautiful. Alrighty, the common ratio here from 3 to 12. So again, we can do negative 12 divided by 3 to get us negative 4. So our multiplier is negative 4. Negative 4 times negative 12 is a positive 48, and that will continue to work. Beautiful. 4 more questions here. Find this common ratio. So we're going from 100 to 50, 50 to 25, 25 to 12.5. So to figure that out, we can do 50 divided by 100. In our calculator, this gets us 0.5, which is the same as 1/2. Notice the numbers were getting smaller each time, so that means we are multiplying by a fraction, or we could also think of this as dividing by 2. So multiplying by 1/2 is the same as dividing by 2. So that's our common ratio here. Beautiful. Write the explicit formula for the geometric sequence. So we have a sub n is our first term times the common ratio to the n minus 1 power. So our first term in this sequence is 100. Our multiplier, we remember from the last question, was 1/2 to the n minus 1. That looks like option C, right? We put our A1 first, and then our multiplier goes in the parentheses. Beautiful. 2 more questions. What is the 11th term of the sequence? Ooh. So let's think about what our equation would be. So what is the first term of this sequence? -2. And our common ratio, how do we go from -2 to a positive 10? So if we had a negative and it becomes a positive, that means we multiplied by a negative number. And 2 times 5 is 10. So -2 times -5 is a positive 10. 10 times -5 is a -50. -50 times -5 is a positive 250. So that does work. There's our formula, and we want to find the 11th term, right? So that means our n is 11. So we have a sub 11 is -2 times -5 to the 11 minus 1. So in our calculator, we have -2 times -5, and then you can hit this button, a to the b, to get your exponent, and that was 11 minus 1. If I put the exponent in parentheses, it'll stay up there as 11 minus 1. Beautiful. So it has gotten big really quick. This is -19,531,250. Woo! With these geometric sequences, because we're doing our multiplication, they're going to climb really fast. Beautiful. And our final question is, you have $729 in the bank on day 1, $243 on day 2, $81 on day 3, and it wants us to find the formula for the sequence. So we have our a sub n is our first term, which is 729, times some ratio to the n minus 1. So already we know it can't be C or D because the first term, 729, has to be in the front. That's the same for both types of sequences. Our ratio, well, what's 243 divided by 729? Or what's 81 divided by 243? Use this division to work backwards to find the common ratio. Notice the numbers are getting smaller, so it's going to be a fraction. So we have 243 divided by 729. If we write it as, if we click this button over here on the right, it will turn it into a fraction, and we get 1/3. And the other one was 81, or what was it? 81, yeah, over 243. You'll see that's also 1/3. So our multiplier in the parentheses should be 1/3. Good, because they're getting smaller. Yay! So that was the end of the quizzes, my friends. Hopefully you're feeling a bit more comfortable with geometric sequences as we get to the end of our week. Take care. Reach out to me if you have any questions at all, and I will chat with you all soon. Bye, y'all.